Alright, the inspiration for what I want to do today, I was browsing several videos. Basically, the thing I was doing some searching on the Kepler triangle, which is a triangle, it turns out, you can construct from the golden rectangle, just as you can construct the golden triangle from the golden rectangle. Anyhow, so I was looking at what it says is Divertad Producciones, from this Javier Romanac. And he's got, there's something about phi, chapter 12, Pythagoras' theorem and the golden ratio. And he says that he's come up with a whole class of triangles, which, you know, basically they're all similar triangles. They'd be similar triangles of different relations, but they all boil down to the fact that you've got a 1 by 2. All right, now there's a lot of things about a 1 by 2 that keep showing up in doing things with phi. So I'm going to go ahead and I'm going to go ahead and start creating a 1 by 2 here, constructing. Let me say constructing. I keep having this problem. Okay, so I put two squares together. That all together makes up a 1 by 2 rectangle. Okay, so we'll just hide that part, and we'll hide this part, and we'll see that we can construct a 1 by 2 rectangle from that. Also known as the root 4 rectangle. It's a 1 by 2 rectangle. Now, actually, I don't even care about the rectangle. What I care about is a triangle. So we'll make a triangle here. We'll construct a 1 by 2 triangle. Okay, so now, having done that, here's the interesting thing he says about this. He says that when you unfold this, any 1 by 2 triangle, you get the golden ratio. So let's go ahead and do it. So we'll take this length, first of all, and we'll just simply draw a circle on that. Okay, why didn't that work? Okay, we didn't have the circle tool selected. So we'll draw a circle on that. And we'll extend the line here, and let's see. Let me go back and try that again. Okay, so we're gonna. I'm gonna start by straightening the hypotenuse to go with the short side of the triangle. Okay, so we'll draw a circle from here to here. Okay, and then we'll extend the line of the short side of the hypotenuse. And we'll put an intersection point there, okay? So this line, from this point to this point, now represents the short side of the triangle plus the hypotenuse of the triangle. Okay, so now we're going to take this as the center of a new circle. So from there to there, okay? And that represents us straightening both of those lines out to compare to the middle line of the triangle. So we'll draw from there and there. Okay, so we swept the hypotenuse down to meet the short side, and then we took that entire line and we swept it down so that it now sits between this point and this point, and that is supposed to be in golden ratio with this point and this point. Okay, so we should be able to construct the golden rectangle on this. And so I said to myself, well, I'll do that below here. I mean, the distance between this point and this point would be the same as between that point then and this point below. So all I have to do is draw a couple of perpendicular lines. So perpendicular from here, and then I should have the golden rectangle. And I said to myself, well, if that's true, then I probably also have the golden rectangle above it. So I'm going to start analyzing this by simply drawing a square. So across the bottom here, I'll draw a square, and then the rest of that should be a square. And I'm like, okay, well, that's interesting. Now what if I draw a square above the line? Now this works out even better, because here we see the actual construction lines of the golden rectangle, because we've got a square, and then this circle hits the square at 2 points, and then this right here is the midpoint of the square on the opposite side, and then this is the little line, and you know, that can come down either on this side or on that side, you know, and that fills out the golden rectangle. This is kind of like the with this square, the arc of the circle that fits in between these in between these points here is kind of a mirror image arc. Okay, so let me see here. I'm going to go ahead and just put another midpoint here, and I just want to show you what I mean by a mirror image arc. So from here to here to here, that arc, this corner of the circle here, is the mirror image. So like from there to there, that makes like the rest of a little fish shape. So you see what I mean about it being the mirror image? So that's a mirror image arc. So I'm going to go ahead and I'm going to undo that. And we could do, let's see, well, we can't actually do it yet because I don't have the the other point. So let's just go ahead and do a perpendicular line, perpendicular from there to there real quick, and that's that point. So what a 1x2, you see this this triangle that's within the square here essentially is a 1x2, and I unfolded it in order to give me the golden rectangle. All I had to do is unfold any 1x2 triangle to give me the golden rectangle. Now it's interesting that you can also cut down a 1x2 triangle to give you the golden ratio, you know, or the golden section. You know, so he claims this Javier guy claims this to be something that he's not seen described anywhere else, and I have no problem with that, but clearly there is an obvious relationship where 1x2 triangles kind of lead to the golden rectangle for you. So this is one golden rectangle right here. Okay, and then we've got another golden rectangle immediately below it right here. Okay. Alright, and I'm going to clear this real quick, and I'm going to show you the other thing about the 1x2. Well, let's see. Let's do it a little bit differently. I mean, we can stack two squares together, and we know that two squares, the diagonal of them is the square root of 5. But if we take a line segment, okay, and then let's say we want to make this into a 1 by 2. It's real easy to do that. You take a midpoint, okay, and that's half. So if this is this could be your 2 units now, and if this is your 2 units, then you take you draw a circle on that. You do a perpendicular line from one corner of that. Where that intersects the circle, that gives you a position from which you can draw your other line. Just go ahead and hide some of these. Now that's your 1 by 2 triangle. That's your 1, and the long line on the bottom is your 2, and then your diagonal is going to be the square root of 5. Now if you take and you draw the circle the other way, because let me show you the hidden circle. See, the hidden circle is there. So that's a vesica piscis. That's a 2 circles of equal size separated by 1 radius, the radius which they hold in common. Okay, so there's your circle, and you cut the square root of 5 at that point, and then you draw a circle from the other side, and then you cut the your long leg down. Now that's your golden section, and you can build a golden rectangle that way too. So let's see, I'm going to hide that, I'm going to hide that, I'm going to even hide the intersection point there, and that's your golden ratio there. You can build a golden rectangle upon that real easy. You just you take that as that's your number 1, and then perpendicular line there, perpendicular line there, put a point right there, and that even is your square, and the other part is your little bit that's left over. So just go ahead and take a midpoint there, and we'll need to put one or another line across here, so go ahead and put that as our perpendicular line. So that I assert is our square, and then draw a little circle from there to there, and it's going to hit the end of that line. So that's your golden rectangle, okay? So just take this back just a little bit, and we can just do this again. So perpendicular line from there. So we've got a similar triangle to the one that we had before. Okay, and if we draw a second circle here and use it to cut that, and then draw another circle from the end up to that point, you've cut your line twice. Okay, so we can go ahead and we can hide those points. We can hide this. I'll hide this perpendicular line, and I'll hide this other intersection point here. Now what can you do with that? Well, if you draw a circle from there to there, see, I don't actually think that circle helps you any, but draw a circle from there to there, and draw a circle from there to there. Do the same on the other side, there to there, and there to there. Well, now start taking your intersection points here, and then just start connecting lines from there to there, from there to there, from there to there, from there to there. I guess you didn't need the one at the bottom at all. And there's your star. So just start copying that around there, and so you sort of minimize your construction lines, and then you can just draw line segments across there like that. And that's your 5-pointed star. That's your regular pentagon, regular pentagram. You got it. You got the whole thing right there. And it starts with a 1x2 triangle. Now there's a 1x2 triangle in your square, which you use to do your golden rectangle as well. So there's obvious connections there. There's some sort of an obvious connection to a 1x2 triangle in several different methods of coming up with the number 5. You've got your obvious connection of your square root of 5, you know. So, I mean, I don't know about what's unique about that, but there's an interesting correspondence. Now, yeah, I've gone over 15 minutes, so I need to kind of stop there. But yeah, I think I'm just gonna put this out there, and there's an interesting set of connections. And a 1x2 triangle and the square root of 5 seems to figure in all of these methods, and there's a connection between the golden rectangle and the golden triangle and Kepler's triangle and the pentagram. All right, over and out.